Good morning, dear students. Yes, so previously we have completed the chapter coordination compounds, right? So today we are going to start with the next chapter, that is amines. Okay, next organic chapter, which is amines. Okay, so do you know the functional group? How do we write for amines? How do we represent amines? Anybody? How do we represent amines, students? Yes, how do we represent amines? What is the functional group for amines? Yes, yes, what is the functional group for amines? What is this? Yes, how do we represent this? What is this? It is a amines. Okay, so a representation, so functional group, it is RNH2. Okay, it is RNH2. So amines we represent as RNH2. So please remember this. How do we represent amine? It is RNH2. Okay. So these are amines are nothing but these are the derivatives of ammonia. Can anyone tell me the form? How do we represent ammonia? Yes. How do we represent ammonia? NH3, right? So NH3 is ammonia. So amines are nothing but they are the derivatives of ammonia in which, okay, now you can see ammonia is what? NH3. So this is the ammonia structure. Okay, so amines they are the derivatives of ammonia. Means what? They are made from the ammonia. Okay, they are made from ammonia. How? By replacing one of the hydrogen by R group. Okay, it can be your alkyl group or your aryl group, or you can replace the second or third. So depending upon how many hydrogen atoms you are replacing. Okay, so the derivatives of amines are formed. So what are amines? So these are the derivatives of ammonia. Okay, these are the derivatives of ammonia in which one, two, or three, okay, hydrogen atoms are replaced by a alkyl or a aryl group. Okay, it is represented by what? It is replaced by a alkyl or a aryl group. Is it clear? Yes. So they are derived from ammonia. So we have seen the structure of ammonia. So it has three hydrogen atoms. So either you can replace one hydrogen atom or the second or the third. Okay, all the three. Okay, if you want to replace one, two, or three, all the three. So they give rise to derivatives of ammonia. Okay, they give rise to amines. Fine. So what you are taking, so R can be your alkyl group or it can be your aryl group. Okay, so remember this thing. Okay, so here they have represented. Here you can see. So one of the, so this is our NH3, that is N, H, H, and H. So what we have done here in the first one of the hydrogen is replaced by your methyl group. Okay, so what it becomes? It becomes CH3NH2. Okay, so what is the name? It is methylamine. Okay, the name is methylamine. So this is our primary amine. This is our primary amine. Why? Because one of the hydrogen atom is replaced by a methyl group. Okay, second one. Second one. So what here we have done? Yes, what we have done here. So out of okay, so two hydrogens are replaced by methyl groups. Okay, so what it gives rise to? CH3, N, CH3, and H. Okay, so what is the name of the compound? Yes, so it is two methyl groups are there. So it is a dimethyl amine. Okay, it is a dimethyl amine. Okay, now third one. So what is happening in third one? So nitrogen is there, three hydrogens are there. So all the three hydrogens are replaced by your methyl groups. Okay, so and this is a secondary amine. This is a secondary amine, and the third one is a tertiary amine. Okay, this is a tertiary amine. So what we are doing? So CH3, N, CH3, and CH3. So this is a trimethyl amine because three methyl groups are there. So it is a trimethyl amine. Is it clear? Yes. So you can see there are three methyl groups. Okay, so this is what? So this is the classification of amines. So amines are classified as primary amine, okay, secondary amine and tertiary amine. So why they are classified as primary amine? Because they are replaced by only one, that is one of the hydrogen atom is replaced by a alkyl or a aryl group. Okay, so one of the hydrogen atom of the ammonia is replaced by what? It is replaced by a alkyl or a aryl group. Okay, then so these are generally represented what we have seen. It is represented by RNH2. Okay, so one of the hydrogen atom of ammonia is replaced by alkyl or a aryl group. Then it gives rise to a primary amine. So this is what? Aliphatic amine. Okay. Now, if we see a aromatic, what do you mean by aromatic? If you have a aromatic ring, okay. So this. So what is this now? Okay. This is also a primary amine, but primary aromatic amine because we have a benzene ring here. Okay, because we have a benzene ring. Okay, then it is a primary aromatic amine. Okay, this is a primary aromatic amine. And the above this one is primary aliphatic amine. Okay, it is a aliphatic amine. Okay, fine. So this was about primary amine. Then what is secondary amine? Secondary amine, it is represented as like this. Primary amine is represented like this. So secondary amines are what? When two hydrogen atoms of ammonia are replaced by alkyl or aryl group. Okay, then they are called as what? Secondary amine. So these are generally represented as R, N, H, okay, and R. Okay, so these are generally represented. And these are called as imino. These are called as what? Imino. Okay, so here we have seen one example. Yes, so here we have seen one example. So our one example is what? Secondary aliphatic amine. Okay, our one example is what? Secondary aliphatic amine. Now this one, so we will give one aromatic amine. So what we'll do? One of the R group will be a benzene ring, and another R group is what? Is a methyl group. So what? Can you tell me the name, students? Can you give the name? Try to give the name of this compound. First, this is phenyl, this is methyl. Follow the alphabetical order, which comes first, methyl comes first. So it is a methyl phenyl amine. Okay, so this is our secondary aromatic amine. This is our secondary aromatic amine. And this is what? Dimethyl amine. So this is our secondary aliphatic amine. Okay, now third one. What is happening here? All the three hydrogen atoms of the ammonia, they are replaced by the alkyl or aryl group. Okay. So in this, what is happening? All the three atoms, hydrogen atoms of the ammonia, they are replaced by what? They are replaced by a alkyl or the aryl group. And how they are generally represented? They are generally represented as this. Okay, these are generally represented like this. Okay, so this is the general representation of your tertiary amine. Fine. Now, tertiary amine, we have seen the example of aliphatic tertiary amine, that is trimethyl amine. So, all the three hydrogen atoms here are replaced by a alkyl group. Now, if we see a what? Uh, tertiary aromatic amine, so one of the R group can be your uh, phenyl group, okay, and other can be your uh, alkyl group, okay. So if any one of the functional group is also what your aromatic ring, then it becomes an aromatic amine. So can you tell the name of this compound now? Can you name the compound? So you have two methyls and one phenyl group. So this is a tertiary amine. So can you give the name for this compound? The name for this compound is what? So two methyls are there. So it is a dimethyl phenyl ether. Okay, dimethyl phenyl amine. Okay, so this is the name of the compound. Is the classification clear? So what are amines? Amines are the derivatives of ammonia. So if you replace one hydrogen, it gives rise to primary amine. If you replace two hydrogen atoms, then it gives rise to secondary amine. If you replace all the three hydrogen atoms, then it gives rise to tertiary amine. So depending upon the alkyl or the group, it will give you aliphatic amines or aromatic amine. Now you know what is aliphatic, what is aromatic. Is it clear up to here? Any doubts up to your classification? Yes, students, any doubt up to here? Okay, fine. Now here, next is your physical properties. Okay, next are your physical properties. So the amines which are lower, okay, lower amines means which are having less molecular weight. So these are liquid in nature. Okay, so these are what? These are liquid in nature. So remember that. Okay. And its IR stretch, that is its infrared radiation of NH, it forms in it 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 falls in 3300 to 3500 per centimeter. Okay. So the IR stretch, that is the infrared stretch of for NH, means when you are doing the IR for this particular compounds containing the NH, okay, so it's peak, okay. So when you see the IR this, so they will be peak like this, okay. So this particular line, this represents your NH, okay. When it falls in 300 to 300, 500, okay, in this particular range, if it falls, then this represents that the compound has a NH bond in that, okay. So IR stretch for NH bond, it falls between 3300 to 3500. Then amines are water insoluble. Why? Because of the NH bonds. Okay. Because of the presence of NH bond, they are not forming hydrogen bonding with water. But these are soluble in solvent. So because NH, okay, because what is there? RNH2. Right. So can you see any like hydrogen bonding here? No. Okay. So because there is NH bond, they cannot form any hydrogen bonding with water. So because of that, they are insoluble in water, but they are soluble in organic solvents. Okay. So, so this is the important like physical properties of your amines. Okay. Then we have seen the classification of amines. Okay. So if one alkyl group is attached, okay, then primary. If two alkyl groups are attached, secondary. If three, then tertiary. If likewise, if one aryl group is attached, primary aromatic amine. If two alkyl groups are attached, secondary aromatic amine, and if three alkyl groups are attached, then it is a tertiary aromatic amine. Fine. So this is was about the your okay, fine. So now we'll see the nomenclature before, okay, before going to the main concept. So let us see the nomenclature, how to name this compound. Right, that is very important, how to name the compounds, right? So before knowing how to name the compound, we cannot proceed. So let us see the nomenclature. What are the rules of writing the name of the compound? So nomenclature. So whenever we are seeing in IUPAC, we are following what IUPAC system. So in IUPAC system, our aliphatic amines, okay, aliphatic amines. So these are named as alkyl amines. These are named as what? These are named as alkylamine. Okay. So when you are discussing about what, when we are discussing about the aliphatic amines, so they are named as alkylamine. Suppose just now we have seen CH3NH2. So how do we name it? We named it as methanamine. Okay, methanamine like that. So the common name is methylamine, but when we name it as Okay, it will be named as what? It will be named as, now suppose if we have this, okay, what will be the name? It will be benzenamine. Okay, benzenamine. So E will be replaced by your ANE. Okay, amine. So this is benzenamine. Okay, like this. So, and what is the common name? The common name is aniline. The common name is aniline. Now here, CH3NH2. It is a methanamine. Okay, it is a methanamine. Methanamine like this. So this is the IUPAC name. Okay. NHCH3, NH2. Fine. Okay. So like this, you have to name the compound. So like this, you have to name the compound. Fine. Let us see other example. Let us see other example. So whenever we are discussing the aliphatic amine, you have to give it as alkylamine. So in aromatic amines, so when we are discussing about the aromatic amines means what? When you have a benzene ring. Okay. So when you have a aromatic amine, the simplest amine is your benzenamine. Okay, the simplest amine in aromatic amine is your aniline. Okay, it is an aniline and this is commonly called as aniline and the IUPAC name is benzylene. Okay, the common name of aniline, this is your simplest aromatic amine is what? It is a aniline and your IUPAC name is benzenamine. Okay, now I'll give you the compounds, so you have to tell me the names. Okay, let me clear this. Hmm. Okay, let us start. So can you tell me CH3, CH2, NH2? Yes, tell me the common name. Okay, I'll tell the common name, you tell the IUPAC name. Because IUPAC name is important. Okay, common name, it can be told. So it is a ethylamine. The common name is ethylamine. What is the IUPAC name, students? Try to name the IUPAC name. Yes. What is the common name, students? The common name is ethylamine. The IUPAC name of this particular compound is ethanamine. Okay, ethane, E will be replaced by amine. Okay, our ethane. Now, ethane is what? Ethane is CH3, CH3. Right. Now, so what we have done here, one of the hydrogen is replaced by NH2. So it becomes CH3, CH2, NH2. Okay, so E is replaced by AIME. So it is ethylamine. Okay, next one. We'll go for next compound. Yes, what is IUPAC name and what is the common name, students? Try answering. Try answering. So this is amine. This is a propylamine. Okay, you can say it as N-propylamine because it is in a straight chain compound. Yes, can you tell me what is IUPAC name system name? Yes, try to answer. What is the name? Try. Okay, I've got some answers here. Propanamine. Yes, baby has answered it right. Very good. It is propanamine. Yes. Okay. So it will be what? Propane. Yes, propane. Okay. Yes, more accurately, it is propane one amine. Yes, Lubna and Sri Varuni has also answered. But only thing what you have to do is E will be replaced by what? Amine. So at first position you have amine. So it will be propane one amine. Okay, should not write year. Only PROPAN. Okay. Similarly, next one. Can anybody answer the next one? So when you have a secondary amine, right? So this is one and one more attached to a carbon. So this is a secondary amine. So it is called as the isopropyl amine. It is called as the isopropyl amine. Can you tell me the IUPAC name, my students? Can you tell the IUPAC name? It is propane, three carbons at the second position. Okay, so one, two, three. So at second position, you have a amine group. So it is a propane 2 amine. Okay, next compound. Next compound, very important. Mark this as important. Mark this as important. It is a trimethylamine. Common name is trimethylamine. Can you tell me the IUPAC name, students? Yes, can you tell the IUPAC name? So it is N dimethyl N dimethyl methane amine. N dimethyl methane amine. Okay. N dimethyl methane amine. Okay. So very important. Mark this important. Next one. Next one. So this is 1, 2, 3, 4 carbon. And you have two, this what? Ethyl groups. So ethyl comes first or butyl comes first. It is, so you have N, okay, N diethyl, N diethyl butyl amine. Butyl amine. Same name for IUPAC also NN diethyl, NN diethyl, NN diethyl butane, butanamine. Okay, so this is butylamine, that is butanamine. Okay, so we'll go for the next compounds. Okay, next compound. Hmm. Next compound, students. This is what? So you have a allyl system. Okay, you have a allyl system, very important. Mark this as important. The name is allyl amine. Okay, the common name is allyl amine. IUPAC name is what? So 1, 2, 3. So it is pro. Okay, prop, 2 in and 1 amine. So this is the name. Next one. Next one. So there are 6. So this is hexamethylene diamine. This is hexamethylene diamine. Okay, fine. What is IUPAC name? The IUPAC name is 6 carbons means it is hexane. Then at 1 and 6 position you have diamine. So it is hexane 1,6 diamine. Okay. Then common name for this compound is aniline. Okay. And what is this? It is a benzene amine. Next compound. This is orthotolidine. Orthotolidine. Okay. What is this? It is a 2-methyl aniline or 2-amino toluene. So you can write any other names. Okay. So 2-methyl aniline or it is 2-amino toluene. Okay. CH3 and with benzene it is called as toluene. Right. So it is either you can give as 2-methyl aniline or 2-amino toluene. Next compound. Yes. Last compound at least you can try. So I'll give you common name. It is a para-bromo aniline. Para-bromo aniline. Yes. You can tell me the IUPAC name. IUPAC name. Yes, you can tell me the IUPAC name. 4-bromobenzene amine. 4-bromobenzene amine. Yes, very good. So it is a 4-bromobenzene, okay, amine. Benzen. Okay. Benzen. Wait, let me clear this. So it is 4-bromo Benzenamine. Okay. So this is the name of the compound. Or you can write it as 4-bromoaniline. 4-bromoaniline. So this is the IUPAC system. So how to write the IUPAC system? Okay. Let us see next one. Okay. So I hope the IUPAC nomenclature is clear. So let us see the structure of amines. Okay. Structure of amine. So, uh, so if I take a tertiary amine, okay. So if I take this, if I consider the structure, okay. So yeah, can you see the structure? Okay, so I consider the tertiary amine. So I've taken a tertiary amine. Okay, so this is a tertiary amine. So let us uh, study about the structure of amines. Okay, so in the amine, okay, you have a central, what you have? Central, you have a nitrogen atom at the center. Okay, so you have what at the center of the structure? You have a nitrogen atom. Okay, so in amines, you have central atom is the nitrogen. And this nitrogen atom is what? It is sp3 hybridized. Okay, what do you mean by sp3 hybridized? sp3 hybridized means what? Around the nitrogens. Okay, so if you have all single bonds like this, so it is called as sp3 hybridized. Okay, it is not having any double or triple bond. So the nitrogen atom, the central nitrogen atom, it is sp3 hybridized. Okay, and they will give you 4 hybrid orbitals, and they will produce 4 hybrid orbitals. And what happens? So out of this 4 hybrid orbitals, 3 orbitals, okay, 3 orbitals, they form sigma bond. They form sigma bond with hydrogen atoms. Okay, they form sigma bond with what? Hydrogen atoms. Either it can be a alkyl group or it can be a aryl group. Okay. And the fourth hybrid orbital. So what we said, they will give you 4 hybrid orbitals, but out of that, 3 will be combined with the hydrogen. And the fourth hybrid orbital contains a lone pair. Contains what? It contains a lone pair. So let me show this. Okay, I'll show you the hybridization. So lone pair of electrons is present in what? It is present in the fourth. Okay, thus the shape of the amines is pyramidal. The shape is what? It is pyramidal shape. Okay, it has a pyramidal shape and the bond angle is 108. The bond angle is 108, which is less than the tetrahedral angle. Okay, so the bond angle of this amines is what? It is a uh, tetrahedral. Okay, that is a pyramidal shape and which is less than 109.5, that is 108. So if I write for nitrogen, what is nitrogen? It is 1s2, 2s2 and 2p3, 3, 4, 5, 6, 7. So nitrogen in ground state. Okay, nitrogen in ground state is what? So we will consider 2s2. Okay, so we are going to consider what? We are going to consider the outer orbitals. That is our 2s2 and 2p3. Okay, 2s2 and 2p3. So if I write for all, so it is what? 2s2 and 2p3. So this is s and p orbital. So nitrogen, when it gets excited, okay, when it gets excited, so these are the inner orbitals. So these we are not making use of. So now what will happen? So you can see here, okay. So there are four hybrid orbitals. Okay. So out of these four orbitals, what you can see here, so this is in ground state. Okay. So this is in ground state and this is in, so this is in ground state and this is in excited state. Okay. Now here what you can see when it is in excited state, so it will make it will make use availability of four hybrid orbitals. So one, okay, two, three, and four. Four hybrid orbitals are there. Out of these four hybridals or orbitals, okay, nitro with hydrogens. Okay, so if I'll show you this also. So one, two, three. So when it combines with four hydrogens, three hydrogens, right? So it will forms what? It forms the, so here you can see, first I'll explain you the ground state. So out of, so these are the four hybrid orbitals which are available. So out of these four hybrid orbitals, three will form what? Sigma bond with hydrogens. So these are the three bonds. Okay, so it forms three sigma bonds with hydrogen. Okay, and the fourth hybrid orbital, this is what? This consists of this lone pair of electron. So these three are what? This one, two, and three. So either it can bond with hydrogens or it can bond with the alkyl or aryl groups. Okay. So these three orbitals, they form sigma bond with hydrogen atoms or alkyl or aryl groups. And the fourth hybrid orbitals, they form what? They contains of lone pair of electrons. So because of the lone pair of electron, the shape is a pyramidal shape. Okay. And because of the presence of the lone pair of electron, the angle is reduced from 105 to 180 degree. Okay, so it has a pyramidal shape. So this is the structure of ammonia. Is it clear? So this is the structure of ammonia. Is it clear up to here? Yes. Is it clear up to here? So next we are going to start with the preparations. Okay, next we are going to start the preparations of amines. Okay, let's just start with the preparation of amine. So what all are the important, okay, in your syllabus? So that only we will discuss. Fine. So the first one is by reduction of nitro compounds. So first one is by reduction of nitro compounds. So So first one, nitro compounds. Then we are going to see with what? The reduction of nitriles. Okay, next we are going to see a reduction of amides. Okay, then we are going to see Hoffman bromamide degradation reaction. Okay, so these are the important preparations which are included in your syllabus. So whatever they are included in the syllabus, so we are going to do that only. Then we are going to do an monolysis. Okay, monolysis of alkyl halide. So that is the reaction with the ammonia. Then we are going to see the real phthalate synthesis. So these are the important. So 1, 2, 3, 4, 5, 6. So 6 methods of preparation. They are included in your syllabus. Okay. So first, let us see the reduction of nitro compounds. Okay. So first, let us see the reduction of nitro compounds. So reduction of nitro compounds. So take the reaction. So you have a nitroalkanes. Okay, we have a nitro compounds, or we have what? We have a nitroalkanes. So nitro compounds are reduced. Okay, how they are reduced? They are reduced to amines in the presence of reducing agents like your tin HCl, or you can use FeHCl. Okay, or you can use uh, H2, okay, nickel in the presence of platinum, palladium, you can use anything. So you can do catalytic hydrogenation. Okay, you can do catalytic hydrogenation by using what? H2 in the presence of nickel, or you can use platinum, or you can use palladium. Okay, so these are the catalysts we can use in our when we are doing catalytic hydrogenation. So either H2 in the presence of nickel or platinum or palladium. So these are the reagents which we are using in catalytic hydrogenation. So this is the condition, okay, for reducing our nitro compounds to amines. Okay, so we are going to get what? Amines plus 2H2. Fine. So what we are doing? We are reducing our nitro compounds. So first reaction is what? Reduction of nitro compounds. Reduction means what? Addition of hydrogen. Okay, addition of hydrogen. So here we can see here. So we are adding hydrogens. Okay, so we are removing oxygens. We are removing this oxygen and we are adding hydrogen. Fine. So this is the first reaction where we are doing reduction of nitro compounds. So we are getting from nitro compounds, we are going to get amine. Okay, we are going to get amine. So let us see examples. So first example is CH3, CH2, NH2. Okay, plus 6 hydrogens in the presence of tin HCl. Okay, can anyone tell me the product? Can anybody tell me the product? Can anybody tell me the product? Yes. And let me give you one more example with aromatic hydrocarbon. So this is primary. Let us take aromatic also. Okay. First one, what is the answer, students? First one, sorry, this is NO2, CH3, CH2, Na2. So what we are going to get? We are going to get CH3, CH2, NH2. Okay, so the name of the compound is nitroethane. This is nitroethane. From nitroethane, we are going to get what? Ethanamine. Ethane amine. Okay, ethanamine plus 2H2. Okay, this is what? This is a nitrobenzene. This is a nitrobenzene. We are doing reduction on that. What we are going to get, students? What we are going to get, students? Yes, we are going to get aniline. What we are going to get? Aniline plus 2H2. Is it clear? Is it clear? Okay. One more preparation. One more preparation we will see. Okay. Second preparation is by reduction of nitriles. What do you mean by nitriles, students? By reduction of nitriles. What do you mean by nitriles? What do you mean by nitriles? Yes, what do you mean by nitriles? So next one is by reduction of nitriles. So RCN, cyanides, or you can say as nitriles. Okay, RCN. So cyanides. So nitriles, when you are doing reduction. Okay, reduction means again addition of hydrogen in the presence of, okay, either you can use what? You can use lithium aluminum hydride. So what is the reducing agent used here? So the reducing agent is either you can use lithium aluminum hydride, so it is a strong reducing agent, or you can use sodium in amalgam. Okay, sorry, sodium in alcohol, sodium amalgam in alcohol. Okay, sodium amalgam in alcohol, or you can use the catalytic hydrogenation. So again, what is catalytic hydrogenation? So in catalytic hydrogenation, what we are making use of? We are making use of hydrogen in the presence of nickel, palladium, or platinum. So we can use any one of this with hydrogen. Okay. So these are the reducing agent which we are making use for reduction of nitriles. That is from cyanides, okay, to amines. So we are going to get what? RCH2 NH2. Okay, you are going to get a primary amine. Okay, so nitriles, okay, it is consist of what? It is consist of a triple bond. It consists of a triple bond. So from nitriles, we are going to get a primary amine. So these are the catalytic. So we can use H2 with nickel, or we can use lithium aluminum hydride, or we can use sodium amalgam, okay, in alcohol. So these are the reagents which we can use. So let us see the example. Let us see the example. So CH3CN plus 4 in the presence of lithium aluminum hydride. Yes, can anybody tell me the answer? Can anybody? So this is a ethane nitride. This is a ethane nitride. Yes, can anybody tell me the answer? Can anybody tell me the answer? So let me take a aromatic amine. Okay, let me take a aromatic nitrile. Yes, let me take aromatic nitrile. Can anybody tell me? Yes. So this is a benzene nitrile. Can you tell me the answer for first one? What is the answer for first one, students? Answer for first one. So what will happen? CH3, Cn will be converted to CH2 and NH2. Okay, so across this double bond, yes, you're going to get ethanamide. So what is there? So C triple bond N is there. So you're going to add, okay, you have to break the two bonds. So these two bonds are replaced by, you are adding two hydrogens, you are adding two hydrogens. So we are adding four hydrogens across this triple bond. Okay, so across the triple bond. So what is there here? So R, C, triple bond N. So after breaking this hydrogen, okay, after breaking this hydrogen, we are going to add hydrogens here. Hydrogen here, R, CH2, and H2. Okay, so like this we are going to get. Fine. So this is answer. Yes, very good. Baby has answered ethanamine. Very good. Okay, it is correct. Ethanamine. Second one. Can anybody tell me the second one? Second one. So it will become what? Benzene ring will be there. Then CH2 and NH2. So it is what? It is a benzyl amine. It is a benzyl amine, or you can name it as 1-phenyl. Okay, 1-phenyl methane amine. Okay, 1-phenyl methane amine, or you can name it as 1-phenyl methane amine. Got it? Is it clear? Are these two preparations clear? Are these two preparations clear? Yes. Are these two preparations clear? Okay, fine. Others? What about others? Okay, so we are left with four more preparations. So that we will see in tomorrow's class. Okay, so today what all things we have discussed? We have discussed what are amines. Okay, what are amines? Then we have discussed the classification of amines. Right, we have discussed the classification of amines. Then we have discussed the structure of amines. Okay, we have discussed the structure of amines. Then we have discussed the IUPAC nomenclature. Okay, we have discussed the IUPAC nomenclature. Then what all we have discussed? Then we have discussed the so there are six preparations. Okay, methods of preparation, how we can prepare. Out of that, we have seen two methods of preparation. Okay, and we have seen the physical properties also. We have seen the physical properties also. Okay, so in the next class, we will see the other four methods of preparation and the remaining things. Is it clear? Yes, any doubts? So please go through the things, whatever I have told today. Okay, don't wait for the last moment. So please practice it daily, the name reactions. Okay, fine. So anything you want to ask, any doubts? Okay, fine. So I shall end the session here. Okay, we'll meet in tomorrow's class. Thank you.